Hi everyone, welcome in this newest video. My name is Johan. Together with me is a very special guest. It's Gijs from Zerto. In the next 3 videos, we're gonna dive into Zerto's solutions, the architecture, the use cases, and how you would like to ideally set up those solutions to make them work. Gijs, where would you like to start today?
So today, first of all, thank you for having me here. Wonderful studio, by the way. We're pretty jealous. We're going to start with the basics. We're going to start with the architecture, with our main components. Talk a little bit about our main use cases, our main capabilities. Zerto, we're delivering the Zerto IT Resilience Platform. And the IT Resilience Platform is basically a solution, software-defined, software-only solution that delivers capabilities like disaster recovery, mobility, cloud mobility. I can move and mobilize workloads from between different clouds, between different hypervisors, between different hardware layers. So really offering true workload mobility, but also helps you solve for backup use cases. And when I talk about backup use cases, we typically refer to operational recovery. So recovering files, VMs, the more things where you typically would go to your backup to, now use Zerto to replicate and recover those workloads.
Okay, cool. And you already drew, I guess, 2 sites with, like a site with hosts, storage in a vCenter, and the same thing here.
Yeah, absolutely. I think a lot of people will recognize this one, probably in a little bit of bigger scale. But these are typically how you find VMware sites. There's a vCenter environment, there's multiple hypervisor hosts, there's VMs, workloads running on top of those, there's some kind of storage solution in there. Zerto by itself, software-defined, software-only. We don't really care about the technology that's being used, whether it's VMware, vSphere 5.0 and up, or Hyper-V, any type of storage, vSAN, iSCSI, Fibre Channel, you name it, we all support it because we integrate into the hypervisor.
Right.
So let's start with the components. So what do we need to build a successful, resilient, software-defined data center?
Right.
So the first thing we need is our management component, which we call, and you'll probably see that in the other videos as well, 3-letter acronyms, we love them. The ZVM, Zerto Virtual Manager. This is the management component.
You need one per site, right?
Yes, every site or every vCenter or every hypervisor management tool needs, it's a one-on-one relationship.
Right, okay.
We use the integration with vCenter to, one, auto-discover what's on that site. So what VMs are living there, how many data stores, what networks, you name it. We also use it to see what's happening to the VMs. Are you initiating a storage vMotion? Are you initiating a vMotion? So we can move along as the environment moves along as well. So this is the management component. UI, API endpoint, orchestration, automation, all being initiated from the ZVM. Now, as soon as that one's installed, it has discovered your environment, we're going to deploy what I like to call the worker bees of the solution, the virtual replication appliances. You'll notice an acronym that you've probably seen before, VRA, Virtual Replication Appliance. We started using it back in 2009, so we claim original owner, original gangster. And you install them on each and every hypervisor host you have in your environment.
Right.
So it's a scale-out architecture. You have a lot of hosts, you have a lot of appliances. You don't have a lot of hosts, you don't have a lot of appliances. So this is true scale-out. It's fairly small. It's 1 vCPU, 3 gigabytes of memory, and it is responsible for replicating all the traffic to the target site, or actually only the traffic of the VMs living on that specific host.
Right.
You also install them on the target site. The reason is once you've done a failover, you might want to replicate back as well. So you need those replication appliances on this side as well. And these also handle the incoming traffic from the source virtual replication appliances. So as soon as you have everything set up, so this is up and running, there's connection, IP connection between the ZVM, I've paired my sites. I can pair multiple sites. We support one-to-many replication. So I can replicate to this site and replicate locally and replicate to a cloud site because We also support clouds. We support multiple clouds. We support like VMware-based clouds, like Azure VMware Solution or IBM Cloud, or native AWS and native Azure as well. So I could use that as a target as well. So go both on-prem environments or cloud environments, or between those. Like I said, we're completely agnostic, so there's a lot of choice there. So now I can actually set up my replication. Replication is key because I need to get my data from A to B. On top of that, of course, we have automation orchestration built in, but I'll get to that in a later stage. Now, the way we replicate is we create virtual protection groups. And virtual protection groups make up an application or an application chain, or maybe even all the VMs that belong to a certain business unit. And that's the logical entity on how we replicate. There's a little bit more magic to that, because if I configure all these VMs to be part of a virtual protection group, we'll also replicate them consistently. So that means that even though they might be on different storage subsystems, different clusters within vCenter, different hosts, every single I/O generated by all the VMs is being replicated while maintaining the right order fidelity across all those VMs.
Right, and that replication group, the properties of the group are being dictated or can be dictated by an SLA, right?
Correct. On top of that VPG, I can configure an SLA.
Right.
And the SLA can be, or it has the following components. RPO, so what is the amount of data loss I find acceptable for this application, which we measure in seconds.
Okay.
The reason why is our virtual replication appliances capture every single I/O generated by the VM, automatically compress it, and replicate it to the target site.
Right.
So it's continuous data replication. I'll talk a little bit more about that later on. Testing, and testing is important. You want to test the recoverability of your application. An SLA on testing means I have to test it every 3 months. You can configure it. And if you've not tested it, we'll generate an alert and say, hey, you have not met your SLA. And this is specifically for auditors. They love that.
Right.
You get bonus points for any type of certification you get. But also, journal history. Now, what's journal history? That's actually a quite interesting one. We use journal technology. That means that every single time a VM generates an I/O, we replicate it to the target site. We don't place it directly into a replica, but we place it into a journal. Every VM has its own journal, and in those journals we store all the I/Os that are being generated by those VMs. Every single time a VM writes something, we store it in the journal. The minimum amount of I/O we store is 1 hour. The maximum amount is 30 days. So why do we do that? Well, this allows us to rewind workloads, to rewind a VM, to recover a file from the journal up to 30 days ago.
Basically your retention.
Exactly, the retention of recovery. Now, what we also do is we generate checkpoints in that journal. And the real magic is we generate those checkpoints every 5 seconds. So that means that besides me being able to go back 30 days, I can go back 30 days with increments of seconds. Wow. So I can rewind to 5 seconds ago, 10 seconds ago, 30 minutes ago, up to 30 days ago. All in the journal. So that really allows me to recover from not only disasters, where I typically take the latest point in time, but also things like ransomware or database corruption.
Right.
So it really gives me flexibility in recovery. Besides the SLA, I also configure all the automation and orchestration options for my application or for my application group. Things like boot order, re-IP, what is the network they need to boot into, or what is the security group in a cloud and VNet I need to deploy them in. So the only thing you need to do is actually initiate that failover, make sure they start in the right order, in the right network, and you're up and running.
Right.
making sure it's as smooth as possible. That's why we measure RTOs typically in minutes, because of our ability to automate and orchestrate all those options.
Right.
Now, another thing we've actually added to the platform recently is 30 days is great, but for all kinds of reasons, tax regulation, compliancy, you might actually want to store copy of your data longer than 30 days.
Like 7 years.
7 years, 11 years in the US nowadays with, I think, for like healthcare. So what we have integrated into the platform is what we call long-term retention. And long-term retention basically allows you, on top of the VPG, to configure a retention policy that takes the data as stored in the target site from the replica disk and the journal. So every disk has a replica and every VM has a journal. And together they are the truth. They represent the latest point in time.
Yeah.
So what we can do is take the data that's in the journal and move it to secondary storage. Cheap and deep, data domain, HPE Store 1s, any type of NFS or SMB type of storage is supported right now.
Right.
We're working towards more and more targets, cloud native targets, to make sure that you can offload your data and store it for as long as you want for the most cost effective, or in the most cost effective way. Now the journal is actually quite the interesting technology. So one, it allows you to feed the data into the secondary storage target. Again, we will never have to touch production again.
No.
It's coming from the DR side. So no need to read data from the production side. So it's only touched once using our CDP engine, which has no production impact. So that means
there's no performance hit.
none. It's completely transparent. It's all done in memory. A really efficient way of doing replication and doing CDP. But it also allows us to really quickly recover back in time. Because what it allows us to do is, as soon as you want to initiate a failover, and you want to go back in time, we need to present the VM a disk that belongs to that point in time.
Yeah.
Now we don't want to apply I/O or remove I/O, do roll forward to roll back. So what we do is we have some technology built into the product that allows us to present a single disk to a VM that consists of data that belongs in the replica disk and in the journal. So we know exactly when to read from the journal and when to read from the replica disk.
Right.
Now, another thing that a VM can do is write data. Now, if you're in a failover test, if you've just initiated a failover, all the writes are actually being stored in a third type of disk, which we call a scratch journal. And the scratch journal only gets write I/O. So this is only read, that's only write. So every change, every data generated by the VM on the disk is being stored in a scratch journal. For failover tests, that's really easy because we can ignore that data. So as soon as you stop the failover test, we'll just erase the scratch journal and you're done. For failovers, it's really great because we have what we call a commit policy, fail safe of the failover. So all the writes are stored here. If you commit to this failover, you've tested it, all the application owners say, hey, it's wonderful, it's working correctly, the users can access it, we'll start applying all those changes to the original disk and end up with a single disk. If it's not okay, you need to do a rollback. We'll just simply delete the scratch journal and generate a new one as soon as you've picked your different point in time.
This is also, I guess, a great way to stage your updates of applications, OSs, you name it.
Absolutely. And this is actually what happens to a lot of customers using Zerto. They see more and more use cases they can use us for as a platform. And we'll definitely touch on that in one of the next videos. So as soon as it's done with the failover test, we'll simply delete this and we're all set.
Yeah.
Now, sometimes you might not want to declare a disaster. You might not want to fail over to a secondary site. because if you need to get data back, it will need to go back over the one connection. You don't want to do that. So as we support one-to-many replication, I can replicate to a DR site, but I could also do local replication.
Right.
So that means I create a virtual protection group of an application, and instead of pointing it to a remote target, I point it to a local target. So all the I/O is being replicated to a local storage subsystem. Could be the same one if you use deduplication. There's not a lot of overhead there. And this allows you to do local recovery. Because besides having a journal on this site, you now also have a journal on this site. And they could both have different SLAs. So these could have a 4-day journal to make sure that you'll survive a weekend, an issue that happened in the weekend. And this could have a 14-day journal because that's typically what you store in your backup as well. So instead of going to a secondary storage device with backup software, you just take the replication and recover from your local storage. It's on production storage straight away from seconds ago within minutes because of all the automation orchestration in there.
Nice.
Now, again, if I'm replicating locally, I could still do a copy to a secondary storage target for long-term retention.
Yeah.
So basically what we deliver you is not only this continuous stream of recovery points to 30 days ago, we can take it to 1 year, 2 year, 3 years, 7 years, as long as I have storage years.
Yeah, depending on your requirements, your mandatory compliancy stuff, and okay.
Absolutely.
Awesome.
So this covers both DR, disaster recovery. I can go to a different site. It offers you operational recovery, basically a way to solve for those more backup use cases nowadays, and giving you a way to store data for a longer amount of time on more cost-effective storage.
Nice.
And this is the base architecture of Zerto and its IT resilience platform.
Cool. Okay, guys, well, thanks so much for explaining this to us. In the next video, we're going to dive into multiple use cases that you could integrate with Zerto. And in the video after that, we're even going to talk about what to do with cloud providers. Because as we're talking about a lot of integration, multi-cloud integration, it totally makes sense to integrate it within your cloud solutions as well.
Absolutely.
Okay, awesome. Well, thanks so much. Thanks so much for watching, and we'll see you next time.
Thanks.
Did you like this video? Please subscribe to our channel because we have a lot more where this came from, and you'll be the first to hear when a new video is released.